channel. In this video, we will talk about a recent paper called skweak, Weak Supervision Made Easy for NLP. So the brief idea of this paper is tackling a major NLP problem. So one of the problem which often we face in NLP is the problem of not having enough label data. So this paper presents approach which you can essentially increase the amount of the label data which you have with things like weak supervision. So what is weak supervision? So weak supervision is a famous idea which has been used in multiple papers in NLP. Essentially the idea is that instead of labeling data points by hand, we use some sort of labeling functions or some sort of rule based or a combination of machine learning based techniques to generate labels for our data. So for example, over here in figure 1, they have given a very good representation of what this whole technique all about. So imagine a scenario where you are generating an NER model, essentially a named entity recognition model, and you have some sort of documents with you, but you don't have labels in them. So what you do is you define a set of labeling functions, either heuristic based labeling functions, gazetteer based labeling functions, and we will talk about more what these heuristic and gazetteer stands for. And as you can see, these labeling functions are assigning some sort of labels to these documents. And then what you do is you have some sort of an aggregation function which is applied over your documents, which takes these labels which are coming in from multiple systems or multiple functions and generate a final set of labeled examples for you so that you can generate a final training model for your end application. So this is the basic idea. So they are proposing a set of labeling functions and a set of generative based models which can be used to combine label from different functions which are coming in. So this is the basic idea. So essentially in the introduction section, they talk about the basic problem, why this is used and what's the end application of this system. Because there is a lot of scarcity in NLP, particularly for low resource languages. And in those cases, what happens is you don't have enough training examples. So what can you do to generate more training examples in these scenarios, and what kind of techniques you can use to do that? So SK weak relies on the technique of supervision, which can be said as it is trying to generate a set of programmatically generated label dataset, which can then be combined with a generative model so that you can use it to generate the final labeling dataset for your end application. In this paper, they are applying this technique to the problem of named entity recognition and classification, which is pretty common in NLP. And for the aggregation function, here they are using a hidden Markov model. Uh, so this is basically the overview. Okay, so let's talk about more detail of the paper. So for example, weak supervision, this idea is not new. This is a ongoing idea which has been used in multiple papers. So weak supervision, the idea is that you're using ground truth or some sort of knowledge base to generate your labeling functions. So the way you do some sort of labeling, or you annotate your data in NLP, is what you do is you go over each example one at a time and you manually assign labels to each example. But in supervision and weak supervision methods, what we do is we generate a set of labeling functions and we use those labeling functions to generate label data for us. A particular kind of weak supervision is called distance supervision, which uses some sort of knowledge bases. So you can imagine, let's say, you are training a named entity recognition system, and for that you can use some sort of knowledge base. So let's say if you have a knowledge base specifying what is the name of the country, what is the name of a company, so you can use that kind of data to generate labeling for your set. Okay, so and labeling functions also don't need to be provide a label for each example. As you can imagine that there could be labeling functions which are sparse. So what do I mean by that is essentially there are a set of labeling functions which do not have a label for a set of examples. So that's very much possible. Okay, so this is a basic overview of the paper. So let's talk about what are the labeling functions they have been using. So here they are talking about various labeling functions, things from heuristics, gazetteers, machine learning models, and document label function. And for their overall pipeline, they have used spacey based models, which they said is able to incorporate all these additional labeling based functions much easily. And particularly, they have been talking about the problem of pause tagging and classification. So the first thing which they talked about is heuristic based labeling function. So what is a heuristic? So heuristic is essentially based on simple set of rules, or you can say if else statements. So for example, you want to detect companies in a given text. So you can use something like if there is a word which is followed by a legal connotation, let's say INC or LTD, those kinds of things. And you can specify that, okay, this particular span of text is potentially a company. Similarly, we can do these things for other kinds of entities. So for example, you can say if some condition is satisfied for a given token, you say that this token belongs to this entity. And for example, here they have given a very easy example of how can you define a money detector. So for example, if there is a sentence which is followed by, or if there is a number which is followed by a dollar sign or a euro sign or a pound sign, you can say this is a money token. Okay, so this is the basic idea. And skweak, they have said that they have additional functionality in terms of you can define a window. So you can say if this particular condition is satisfied within a window of, let's say, 5 words, those kinds of things, or if this condition is being satisfied within this prefix. So those kinds of things can be done. The other kind of technique which they talk about is machine learning models. So for example, you can use a pre-trained spacey models to generate named entities for your end input, and use that as an input signal as one of your labeling functions. You can also use something called as a gazetteer, and a gazetteer is nothing but a lookup table. Essentially, the idea is, imagine, let's say, if you have a Wikipedia articles and you can extract all the country names or you can extract all the company names. Now, let's say if you have another database from which you can extract all the people name. Now, what you can do is for your articles or for your words, you can do a lookup in your gazetteer, and using this lookup, you can do some sort of tagging. Let's say, I think that this phrase is a person, or I think this phrase is a company, or I think this phrase is an organization. So those kinds of things. So these are the general ideas. So now the question is, let's say now you have labeling functions which are coming in from different kind of models or different kind of rule-based systems. How will we combine these labels? So for combining these labels, they are proposing an aggregation function. And here the aggregation function is nothing but a multinomial HMM hidden Markov model. So what they do is they define a hidden Markov model over their set of labeling examples, and the hidden Markov model essentially tries to maximize the probability of the whole sequence of tokens. So hidden Markov model tries to maximize, and it considers the labels which are coming in from different labeling function as some sort of votes. So this is the general idea, and they use the expected maximization technique to essentially train their hidden Markov models. Now, one of the things they do additionally in the hidden Markov model is doing some sort of weighting. So you can imagine, because you're using some sort of labeling functions, what could happen that certain labeling functions have a higher false positive rate or a higher rate of wrong labels. And one thing which can also happen is that they could have redundant labels. Let's say if there are labels which are coming in from multiple functions, multiple labeling functions. So they've defined something called a weighting function, which weights different labeling functions together so that you can combine or aggregate different labeling functions together, and so that you can generate the final output of your from your model. And here they have given a very good examples of how you can define various labeling functions. So for example, here they have defined a labeling functions for money, year, date, names, For example, here they have given a sentence: Donald Trump paid this much dollars in federal income, and you can apply this model over consecutive set of labels, and the model will give you a aggregated labeling example data set, which can then be used for your training. They've also given multiple examples in Jupyter Notebook, which you can check in their GitHub page. Now they have talked about what are the results and what are the various labeling functions they have used. So for example, for labeling functions, they're using heuristics for detecting dates, times, percents, and they're also using heuristics for detecting, let's say, things like entities, and using part of a speech tags to detect phrases. They're also using heuristics to detect person names. So for example, if something is appended with Mr. or Doctor, that probably is followed by a person name. They're also using a set of gazetteers where they have a set of Wikipedia articles, and they are using that to detect person, organization, or locations. And over here in table 1, they are giving what's the accuracy score or what's the performance of the model. Uh, Both individual models, which is combined from different labeling functions, and also the combined model, which is aggregated with the HMM aggregated labels. And as you can see, where they are using a majority vote based model, the majority vote model is able to do a token level F1 of 0.64 and an entity level F1 of 0.62. And within each subsection, they have given a good study of how each labeling function is performing. So for example, only with heuristics, they are able to get up to 62 F1 score. Only with gazetteers, they are able to go up to 0.46 of F1 score. With NER model, they are going up to 0.60. All with all doc level, they are going up to 83. And if they combine all the labeling functions with HMM aggregated labels, they're going up to 0.83, and on entity level F1 is also 0.86, 0.76, sorry. So which is pretty good. Uh, Okay, and they've also defined a set of document label labeling functions. So what they're saying is that if a given entity is appearing again and again in a given document, the chance of it being belong to the same category or entity is much higher. So these are the general ideas, and they've applied these similar techniques for sentiment analysis as well. The idea is pretty much the same. So I think this is a pretty cool paper, and this idea could be used to generate additional labeling examples for name identity recognition or sentiment analysis problems. If you like this video, please subscribe to my channel and keep watching for more upcoming videos. Thanks a lot.